Hello once again, class, and welcome to another mock lecture. Today we're going to be talking about an intro to probability, beginning with a few definitions. Okay, the first thing we need to know is what an outcome is. The outcome is the result of an experiment. I like to think about it as it's a thing that can happen. The next thing is an event, which is an outcome or a group of outcomes, particularly that we're interested in. So typically you're finding probabilities of some kind of an event happening, and that's what kind of this video is focused on. It's the introduction to how do you find the probability of an event. So an event is the thing we're interested in. As a quick example, suppose that you want to roll a six-sided die. You can get this. These are the possible outcomes that you could get. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. Suppose that we wanted to find the probability of rolling a 4. And in this case, rolling a 4 would be the event that we're interested in. Maybe we want to find the probability of rolling a number that's less than 5, right? That would be the event that we're interested in. Or maybe we want to find the probability of rolling an even number. And again, the rolling an even number, that's the event that we're interested in. So all of these things are events. The next thing we need to know is what a sample space is. And a sample space is basically the thing that I had drawn on the last slide. It's the set of all the possible outcomes that could happen, right? So it's this thing. This thing is our sample space. It's the set that contains every single possibility that could happen when you roll a standard six-sided die. Here's the sample space for rolling 2 dice. So maybe you roll the first one's a 1 and the second one's a 4. Maybe the first one's a 4 and the second one's a 1, right? All of these things are the possibilities. These are everything that can happen when you roll 2 dice together. There's 36 of them. 36 possibilities exist here. So maybe as an example of an event that you might be interested in, suppose that you want to find the probability of rolling doubles, right? So our event is a collection of outcomes in this situation. It's the set that contains double 1s, double 2s, double 3s, double 4s, double 5s, and double 6s. So there's 6 ways to roll doubles in this set of 36. And that is actually how you calculate the probability of rolling a double. So a probability is essentially the likelihood of an event, a specific event that we're interested in, occurring. Okay, I think about it as it's the proportion of times that the event would occur if the same action was repeated over and over again. So if you roll a dice 100 times, you can expect 16-ish of them to be the number 4, right? 17-ish maybe, somewhere between there. That's a probability. It's the likelihood of an event happening. It's not saying that it's going to happen. It's just saying here's the likelihood, right, that it happens. Mathematically, you can calculate that with just a ratio. If all outcomes are equally likely, which is going to be the case for most of the things that we're going to be talking about, like flipping a coin or rolling a dice or drawing a card, then P of E, the probability of the event, is equal to the number of outcomes in the event that we're looking at. Sometimes I think about it as the number of favorable outcomes, right? The things that we want to get, divided by the total number of equally likely outcomes. So you take the amount of times what we want to happen and divide that by the number of possibilities that could happen. Okay, so I'm paraphrasing here. How many ways, your numerator is how many ways can we get what we want? And you divide that by how many things are possible, which is actually just the size of the sample space, right? So when you're rolling 2 dice, the size of the sample space would be 36. When you're rolling 1 dice, the size of the sample space is 6 because there's only 6 possibilities would that happen when you roll a dice. So let's return to that. Let's actually find these probabilities based on the formula, right, that I just gave us. So let's say we want to actually find the probability of rolling a 4. So we need to know this. We need to remember this, right? Here's our formula. So we're going to take the number of things in the event E. Well, the probability of rolling a 4, there's only one possible outcome for rolling a 4, and it is actually just rolling the 4. And then you're going to divide it by the number of outcomes that are possible, the size of the sample space, which is 6. So the probability of rolling a 4 is 1/6. The next one, find the probability of rolling a number that's less than 5. Again, I wrote it out, probability of rolling number less than 5. How many numbers are less than 5 on a standard die? There's 4 of them, right? 1, 2, 3, and 4 are all less than 5. So the number of things in our event is 4, and the denominator is still 6. So we'd have 4 over 6, which you could then reduce to being 2/3. All right, the last one says find the probability of rolling an even number. So again, how many even numbers exist, right, in our outcome list? Well, you could roll a 2, a 4, or a 6. So there's 3 favorable outcomes out of 6 possible, and so our probability would be 0.5 or 1/2. The thing that you have to be a little bit careful about when you're talking about probability is thinking about it in terms of a percent chance. You'll notice that every single one of these numbers is a fraction. It's something that's less than 1, and that is actually always true for probabilities. Probability in an event is actually always between 0 and 1. And it could be 0 or 1, and that's what I mean by inclusively, right? You could be 0 or 1. Mathematically, we get this inequality. Probability of event is between 0 and 1, but it could be 0 or 1 based on the inequality that's given there. In fact, if you get a probability of 1, then what you're talking about is a certain event. It is going to it's a thing that has a 100% chance of happening. Again, not the same as probability, but you could interpret a probability as a percent chance. So in this case, a certain event has a probability of 1. An example of that might be something like the probability of rolling a 1, 2, 3, 4, 5, or 6. That probability is 1 for a standard die. That is going to happen. One of those things is going to happen. On the other side, an impossible event has a probability of 0, right? Which again, you could interpret as a 0% chance. But a probability is not a percent, and I have a slide about that here in just a second. But an example of that might be the probability of rolling a 7 on a 6-sided dice. That cannot happen. It is impossible, so the probability is 0. All right? But it is important to keep in mind that probabilities, they don't tell you what's going to happen next. If you roll up to a roulette table in the casino and you see that the ball has landed on red like 7 times in a row and you're like, oh, the ball's probably going to land on black next. No, the probability of it landing on red or black is still roughly 0.5, right? There's still about a 50% chance of landing on it either. It only tells you what's likely, right? That's what a probability is doing. So it's not saying, hey, this is going to happen next. It's saying, hey, here's the likelihood of this happening. Okay, so the example I put is if you flip a coin 100 times, it's likely that you're going to get around 50 heads and 50 tails, but that doesn't mean that that's going to happen if you flip 100 coins. It is possible all of them are tails. Maybe you flip 100 coins and every single one of them lands on tails. That's extremely unlikely, but it is possible, right? So that would be part of the sample space when you flip 100 coins. And then the last thing is, before we get into some examples here, that probability is not a percentage. You can interpret a probability as a percent chance, but they're not the same thing. Probability is always a number that is between 0 and 1. So it's a decimal, right? Or a fraction that's less than 1, but still positive. All right, let's do some examples. All right, example number 1. Consider flipping 3 coins. What would be the probability of flipping at least 1, is what that should say, 1 heads? That's probably going to say on for every slide after this. So just pretend there's an E after that. Well, the first thing that we need to address is what is the sample space of this thing? If probability is defined to be number of favorable outcomes divided by number of total possible equally likely outcomes, then we need to know how many possibilities that there are for flipping 3 coins. The way that I do this is I just think about what could happen if I flip 3 coins in a row. First thing that could happen is every single one of them could be heads. Then I think about, well, what if you get 2 heads and 1 tails? Well, I discovered there's 3 ways you could do that. You could flip heads, and then tails. You could flip heads, tails, and then heads. Or you could flip the tails first and then 2 heads. And then I was like, okay, well, what are the different ways you could get 2 tails? So then I found this. You could flip heads, tails, 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 heads, tails, or tails, tails, heads. There's no other possibility for how you could get 2 heads. Those are all of them. There's 3. And then the last one, of course, then is, well, what if you flip no heads? What if they're all tails? So tails, tails, tails would be the last one. So, okay, now we can address the question, what's the probability of flipping at least again, 1 heads here. Well, first thing we need to do is we need to figure out how many of these things in our sample space have a heads in it. And I decided, okay, there's 7 of them. All right, all of these have at least 1 heads in them. So my numerator would be 7. There's 8 things total. So the probability of flipping at least 1 heads when you flip 3 at a time would be 7/8. What if we want to find the probability of flipping exactly 1 tails? Well, same sort of thing. I put the denominator as 8 because, again, there's 8 things in our sample space here. But then I had to count, well, how many of the outcomes have only 1 tails or exactly 1 tails? And I was like, oh, okay, there's 3 of them. 3 of them have exactly 1 tails. So the probability of exactly 1 tails would then be 3/8. Example 2, let's consider drawing a single card from a standard deck. And it's here that we need to talk a little bit about what even is a standard deck. That term is thrown around a lot. So let's decide right now, what is a standard deck? A standard deck of cards has 52 cards total, broken into 4 different suits. There's hearts, spades, diamonds, and clubs. Those are the 4 different suits that exist in a deck of cards. Each suit has 13 cards in it. There's an ace, there's numbered cards 2 through 10, and then there's 3 cards that we actually call face cards that are the jack, the queen, and the king. And I wrote them in ascending rank. So like king is very typically the strongest card in the deck, although it is very common practice to make ace the highest card, but it can double as both the highest and lowest card. But anyway, you can rank the 13 cards. Spades and clubs are considered black, and hearts and diamonds are considered to be red. And then I just, again, kind of put on here, the jack, queen, and king are considered face cards. Okay, so now that we have this, we can talk about some probabilities. And by the way, here is the sample space. This is the entire deck of 52 cards. In the top row, we've got diamonds. In the next row, we have clubs. Then we have hearts. And then the last row is spades. Here's your face cards. And here's your aces. But then you have numbered cards 2 all the way through 10. Okay, and that exists for every single suit. So let's ask this. What's the probability of drawing a 7? Okay, so it can be of any suit. Now, I know there's 52 cards in totality, so my denominator would be 52. I could draw any of the 52 cards that I just showed you in the last slide. Well, how many of those cards are the number 7? And it's these. There's 7 of each suit, so there's 4 outcomes for drawing the number 7 out of 52 total outcomes, so 4 out of 52, or 1/13th, would be the probability of drawing a 7. What about the probability of drawing a black card? Okay, well, again, there's 52 cards total. We're only drawing 1 card in both of these examples. So probability of drawing a black card, well, we need to go to our sample space again. There's 13 clubs and 13 spades. And remember that both spades and clubs are considered to be black. So, okay, there's 13 here plus another 13 here. So that'd be 26 cards. 26 possible outcomes are in our event, drawing a black card. So 26 is our numerator, 52 is our denominator. That reduces to just being 1/2. So very basic probability stuff. I'm going to end it here. If you guys have any questions, please leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.